Problem 6 from the homework, we get that the control rods attached to a lever ABC exert on it the forces shown as in the picture. That means we got a lever that goes from A to B to C with a pivot point at B, and we have three control rods attached at A, one at A, two at C. Those control rods are going to create forces in certain directions to keep the rod in place. Now, the control rod attached at A is giving me a force of 20 pounds going to the left and up and has an inclination of 20 degrees. However, important to note, these 20 degrees are not about the vertical. They are about a perpendicular distance or perpendicular direction to the road. The other roads that are attached at C, one is creating a 20 pounds force down to, and it has also a 20 degrees inclination. Once again, not about the vertical, but about a perpendicular to the lever. And the other one attached at C is creating at 48 force, 48 pounds force going up and to the right, and again has a 55 inclination about the perpendicular to the road. Now, the one thing asked in A is to replace the forces with an equivalent force coupled system at B. That means it is asking me to move this force to B, this force to B, this force to B, to create a force coupled system. And remember, when we create an equivalent force coupled system, we will always have the component of a moment. So the idea is to calculate the moment about B. Now, this would be very complicated if we didn't actually make the proper, let's say, considerations. We could decompose these forces into X and Y, X and Y, X and Y, and then decompose the distances into X and Y distances for the left side of 40 inches and for the right side of 30 inches with this 30 degrees inclination. However, that will give me several combinations to calculate the moment about B. There are easier ways to go. For instance, one of the main tips I can give you is to rotate and make an inclined plane to be a flat horizontal plane. What do I mean? The best way to attack this problem is to rotate it 30 degrees to the right. If we rotate it 30 degrees to the right, we'll see how it slowly, the road gets actually parallel, sorry, to the horizontal. That way, I can analyze these forces and decompose them, not the way that we were, but decomposing at forces applied at C this way, C this way for this 48, for the 20 pounds down and to the right, and for these 20 pounds up and to the left. If you see, we will have a set of two couples. One couple created by this force and this force, another couple created by this force and this force, and one extra force that's creating some certain couple, not couple, but moment, the vertical of the 48 pounds. So this way, we already know what's the distance between these two forces. And surprisingly, the force of the 20 pounds that goes to the left and up here, the component that's parallel to the lever, and the component that's parallel to the lever of these force, they will counter to each other. That means they will be negated, leaving me only with these two forces. So, best way to go is to rotate the view. And we can get that too, since the inclination is not about the vertical, but about the perpendicular from the lever. So let's start. We will divide, or we will calculate one force component for this 20 pounds force that goes perpendicular to the lever. We'll call it force perpendicular. We'll also have this other component that goes down. This is going to be force perpendicular. Since we will have two force perpendicular, we'll calculate it as force perpendicular 1. And this one right here, the one for the 48-pound force, is going to be force perpendicular 2. Why I don't calculate the ones that go parallel? Well, any parallel force to the lever will not create moment about P. We'll only care about the ones that create moment. So let's go for it. Force perpendicular 1, since we're actually having an inclination about the vertical in this case, it's going to be calculated as 20 pounds times cosine of 20 degrees. Force perpendicular 2 is going to be calculated as 48 pounds cosine of 5 degrees. If that's the case, we will get that the force y1 is going to be 18.79 pounds. The force perpendicular to it's going to be 27.53 pounds. Now we can calculate the moments. We will have one couple moment created by these forces of perpendicular 1 times the distance between them. That distance between them is going to include 40 and 30 inches. That means we will have 70 inches times force perpendicular 1. That means 18.79 pounds, like that. And we will have another moment about B that's going to be created by the perpendicular force 2 and the distance of 30 inches, that is 30 inches times perpendicular force 2, and that perpendicular force is 27.53 pounds. We will obtain two different moments. One moment from the couple that's going to be 1315.3 pound inches, and another moment created by this lone force that will be 825.9 pound inches. Now, these two forces, this couple, is going to create a rotation clockwise, as we have seen before, by the same reason. So it's going to be negative. This other force, this force combined with this distance is pushing up from this side to the pivot. That means we create a rotation like this, positive. So this one will be positive. The total moment, it's going to be the subtraction of 828.25.9 minus 1315.3. That subtraction will give me minus 489.4 pound inches. That means when I replace my system, it's going to look a little bit like this. We'll have the lever, pivot at B, lever A, C, the pivot at B, and we're going to move all the elements to B. Now, if I place my force that goes up like this, 20 inches, and the other force that goes down like this, 20 inches, not inches, sorry about that, it's going to be pounds. They will counter to each other. So the only force remaining will be the one that goes this way of 48 pounds. That will have a 55 inclination about the perpendicular direction. And we will have also a rotation that's negative. That means goes like this with a moment of 489.4 pounds inches. That would be the answer for the first part.